Hi, mathletes. You are going to be graphing equations with tables. And after this video, you will be able to create a table given an equation and then plot those points to make your graph. For this third question, we're going to do the same thing. We're given x values and we're going to plug those into our equation with x. Some of you may need a reminder of what these straight brackets are right here. They can act as a grouping symbol, though there's nothing to do inside but evaluate what x is. Those are absolute value symbols. So these straight brackets are absolute value symbols, and recall that we talked earlier that absolute value is just the distance from zero. So distance is always positive, so when you take the absolute value of something, it's going to be positive because it's going to be whatever that distance is from zero. We're always comparing to zero. We're replacing the x value with the given x value. So right in here is where we're going to put -2. So 5 times the absolute value of -2 minus 8. And we're going to do that for each of the rest of our values down our table. Let's talk about how you evaluate that. So the absolute value of -2. Looking at our number line, if we're at -2, how far is -2 from 0? It's 2 units from 0. So that becomes 2. 5 times 2 minus 8 is what we have left. Multiplication is next in order of operations. So 5 times 2 is 10. We still have that subtract 8, and 10 minus 8 is 2. So our ordered pair is -2, 2. If we want to plot that, -2 is left 2, +2 is up 2. So we have a point right there. Continue evaluating for the rest of the table and writing those as ordered pairs. So we got these ordered pairs when we plug them in. Let's go ahead and plot those. When x was -1, y is -3, that's right here. At 0, -8, that's here. At 1, -3 is here. And then at 2, +2. So let's take a look before we talk about what function this is and the rate of change. Let's calculate the rate of change in our table. So let's look at the change in x and the change in y. And again, we'll do that over here, making sure that we're just focusing on the y coordinate of the ordered pair. So I found my change in x to be increasing by 1 for each of my values, and my change in y, we were decreasing and then increasing. Again, remember, use that built-in number line to your coordinate plane. So if I'm at 2 and I'm going to -3, I'm going to the left. That's why that is -5. That's 5 units to the left. From -3 to -8 is also left 8. And then when I'm at -8 going to -3, I'm going back to the right 5. And then from -3 to 2 is also to the right 5. That's where these values come from. So our rate of change is a plus or minus 5/1. So we have opposite ROCs. We could also say that there's a vertex or a turning point. This hopefully tells us from last unit that this is absolute value. And the shape of our graph is going to be a V shape. And you can see that here, that it is made up of 2 lines. Let's sketch those in now. Looking at question 4, we have yet another new equation. And so we can see here that our x value, our variable, is now an exponent. So it's in a different place. But we're still going to replace our x with the different x values that we have in our table. Let's get that set up now. So we can see here that our unknown is this exponent, and so -2 is going to go in there as our exponent. So we're going to have 4 to the -2 minus 9 for the first row. So you can see I've put in my exponent, my x value as my exponent. Maybe a little bit hard to see. I wrote that kind of small. Let me zoom in. And repeated multiplication with a negative exponent, you may not have had much or any practice of. So let's look at a calculator and how to calculate that. So we need to evaluate what 4 to the negative 2 is first, because we only have exponent and subtraction, and exponents come before subtraction. So we're going to put in 4. And this button right here, let me make sure you can see that. This button right here on my calculator, A to the B, is the exponent button. Some calculators might be X to the Y, or some might just show a caret, the little upside down symbol like that, upside down V. And so now I need to type in negative 2. This particular calculator does not have a negative symbol, so I'm going to use the subtraction key. And there we go. Oops, I'm out of that. Let me try that again. Let me get up into my exponent. You got to be up in that exponent. There we go. So here you see 4 is to the negative 2, and it's already showing me my answer here, but it comes out to a decimal. It's actually 1/16 is where that comes from, and we'll be exploring that more later. Really, right now, we're just going to try to see what that value is. So we have here that we get 0.0625 minus 9. I'm going to continue using my calculator for this. Sometimes you can just hit subtract and it'll pull the answer down. Most calculators are that way. This one I have to actually type in using my answer key. I have to press that. So I'm going to do that. I'm going to take my answer and I'm going to subtract 9 and then hit equals. And so I get this negative 8.9 here. So I'm going to write that down. We don't have to have all the decimal places. We can't graph those. They're not going to show up anyway. So I have negative 8.9 is going to be sufficient for that. Let's take a look at the next one. You are going to take 4 and it is going to be raised to the negative 1 and hit equals. We get 0.25. That's because that's really a quarter. So we have 2,500, so we have to subtract by 9. And so I'm going to go back over to my calculator. I'm going to take that answer and I'm going to subtract 9. And you'll see that I get negative 8.75. We're going to do one more together before you do a couple on your own, because 0 as an exponent is also a little funky, something you may not have seen before. We'll be exploring that more later this year. So we're going to type in 4 exponent key and put in 0 and enter. It comes out to 1, so it's not as messy as the decimal, but it is something that you may not be familiar with. So 4 to the 0 power is 1 minus 9. And if you really want to, you can go ahead and put that in as in your calculator, or you can just subtract that out and you get negative 8. If you want to see on your calculator, you'd want to put the answer in or retype that 1 minus 9 does give us negative 8. So you can see we have a little bit of cluster. We have negative 8.9, negative 8.75, negative 8. We're getting smaller here. Let's keep going on our table. So 4 to the 1 power is just 1 4, which is 4. 4 minus 9. Again, if you're at 4 and you subtract 9, you're going to end up over here at negative 5. So our ordered pair was 1, negative 5. For plugging in 2, we had 4 squared. That's 4 times 4 is 16, minus 9 gives us 7. So let's plot these ordered pairs. I'm going to start with plotting the things that are integers. That's just no decimals. That makes it easier to plot. Let's take a look at those. So 0, negative 8 is down here. 1, negative 5, write 1 down 5. and 2, 7, way up here. We're seeing some big jumps. And then over here, super tiny. At -1, we're at -8.75, so pretty close to -9. And at -2, we're even closer to -9. So this is a curved graph. Let's take a look at what the change in X and change in Y tell us. So our change in X's are all increasing by 1. Our change in Y's are decreasing by difference amount. Again, I'm going to look at my integer values first just because they're easier to calculate. So from -8 to -5, I'm going to the right 3. So that's going to be +3 here. And from -5, I'm going over to 7. That is increasing by 12. So we're going to have to do this one. So if you're going from negative 0.875 to -8, you may be able to see that this is an increase. You're going to the right of 0.75. And that's probably enough. You could go through and find this other difference, but you don't need to. Hopefully you just recognize that we're increasing by an increasing amount, like our change in X, our second difference is not constant. If I'm looking here, I see that my difference is 9 between 0.75 and 3 is not 9, so we know that the second difference isn't constant. So you're looking for that multiplier. That's the next thing that you'd be looking for. And we know we're getting bigger, so it would be multiply. Again, I'm going to start with my integers because I see that 3 times 4 gives me 12, and actually 0.75 or 75 hundredths times 4 does give me 3. So that tells us that our rate of change is increasing or times 4, and so our rate of change is increasing by a factor of 4. And you may have just been able to tell this from the table or the graph, but this is an exponential function. So we'll be looking at, we got 4 different functions from 4 different types of equations, and we're going to try to make observations about those equations and how it relates to the graph in the table in our lesson today. A quick summary of the process: you are going to graph the function you're given an equation. So you have to start by completing the table, and to do that, you need to substitute the given x value, these values, in for x in your equation. And then we simplify the resulting expression to find y. That's what's going to give us our y values. And then you plot those points. So this is just the last example we did, number 4. After you graph on your practice, we're going to try to make some observations across the 4 different types of functions and their equations.